There are 330 million people living in the United States. Our intuition suggests that measuring a population this size requires millions of individual interviews to avoid a massive margin of error. In reality, statisticians can understand the habits of the entire country by talking to just 2,000 people. Reducing a massive, chaotic crowd to a tiny handful of isolated individuals breaks our mental model of how data works. It feels too small. Consider Ireland. The entire country has a population of just 5 million people, yet the survey requirement remains unchanged. To get an accurate read on Irish habits, a researcher still needs to interview exactly 2,000 people. We falsely conflate the total size of a population with the size of the sample needed to understand it. But the math of probability ignores proportions. It only cares about the absolute volume of data points. In market research, accuracy is dictated strictly by the absolute size of the sample, regardless of how large the total population is. This chart shows how survey responses vary at the start of a study. The first dozen answers will swing erratically, making it impossible to spot a trend. However, after just 30 interviews, the extreme fluctuations flatten out, and a reliable pattern begins to form. By the time you reach 2,000 random interviews, you achieve a 95% confidence level. Your margin of error, the expected difference between the true population and your results, drops to just 2.2%. This is a sample size ready reckoner table used by statisticians to guarantee these precise error margins. A sample of 2,000 yields the same accuracy whether you are measuring a small city or an entire continent. There is a catch. This math only works if everyone in the population has an equal, random chance of being selected. In the field, true randomness is ruined by non-response bias, the fact that people who refuse to answer surveys often think differently than those who do. While the mathematical theory of absolute size is perfect, real-world constraints make pure randomness impossible to maintain. Researchers must find a more practical way to select their targets. Because people screen their calls, ignore emails, or simply refuse to participate, a pure random lottery faces insurmountable bias. Researchers rely on a mathematical shortcut to bridge the gap. The primary solution for consumer markets is a technique called quota sampling. Quota sampling is a method where researchers select individuals based on specific demographic traits to ensure the final group mirrors the broader population. Instead of leaving the survey to chance, quota sampling uses census data to intentionally build a miniature, demographically identical mirror of the target population. In consumer research, an engineered demographic reflection provides far more reliable data than chasing the ghost of pure, theoretical randomness. Those quota rules work for everyday consumers, but when you apply them to business research, where companies are the subjects instead of individuals, the entire system breaks down. In the chemical industry, market participants range from tiny regional mixing plants to colossal multinational giants. This bar chart illustrates the extreme inequality of corporate markets, governed by the Pareto principle. The Pareto principle states that a tiny fraction of participants, often just 20% of the companies, control 80% of the total industry sales. If a researcher randomly selects 100 chemical companies but accidentally misses the few industry giants at the top, the data is useless. You would be modeling the entire industry based on the habits of its smallest, least influential players. In business markets, statistical randomness is a liability. Accuracy requires deliberate, targeted judgment to ensure the giants are always captured in the sample. Even with a clean dataset, researchers face a difficult reality. Human beings constantly lie to themselves about what they actually want. When asked directly, customers will claim that low prices are their top priority. This is their stated importance. But their actual loyalty is often dictated by hidden factors, like technical support or brand trust, known as derived importance. This scatter plot compares what customers claim is important against their actual behavioral data. Statisticians bypass human self-deception by using correlation techniques to map these points, revealing the gap between what people say and what they do. True behavioral drivers cannot simply be requested in a multiple-choice survey. They must be mathematically derived from the silence between the words and the actions. The ultimate goal of the researcher is to take this sea of contradictory survey data and forge it into clear, highly targeted audiences. To do this, they use factor analysis. Factor analysis is a mathematical method that condenses dozens of random, noisy survey answers into a few core underlying needs. The next step is cluster analysis, an algorithm that groups individual respondents into distinct behavioral tribes based on similarities. This cleanly slices a monolithic market into actionable segments, separating price fighters who care only about the bottom line from service seekers who prioritize support. Effective market research relies on the counterintuitive science of extracting hidden signals from absolute numbers.